Assalamu alaikum wa rahmatullahi wa barakatuh. I would like first to welcome you all in our fourth session. Our fourth session of the Symposium of Identifying the Impact of Artificial Intelligence on Academia and Job Market. In this session, we will have three speakers, Dr. Arij Al-Wabili, and then after that, we will have Dr. Manal Kalkatawi, and then after that, we will have Dr. J Siegel. First, let me welcome you all, and I'm honored to introduce our first speaker, Dr. Arij Al-Wabili. Dr. Arij is the chair of software engineering in College of Engineering at Al Faisal University, and she's the director of Al Faisal AI Center, a center of excellence for artificial intelligence, research, teaching, theory, and practice. Welcome, Dr. Arij, and the floor is yours.
Thank you very much, Dr. Al-Hudali, and welcome everyone. If you allow me, I'll be sharing my screen to start. All right. بسم الله الرحمن الرحيم. السلام عليكم الحضور الكرام. بداية أود أن أشكر جامعة الملك عبد العزيز لتنظيم هذا اللقاء. I'd like to extend my appreciation to King Abdulaziz University for organizing the workshop. It has been interesting in all tracks and the topics that have been covered in the previous day and earlier today. Carrying on the theme of the impact of AI on different aspects of academia and the job market, the session is focused on research and innovation related to that. And what I'd like to do is highlight an area in which we are actively engaged in at Al Faisal University. As Dr. Al-Hudali highlighted, I'm affiliated with Al Faisal University in Riyadh, Saudi Arabia. I'm also a research affiliate with MIT in the US. And the topics that I'd like to share with you today are mainly in the area of health tech or neurotech specifically. I'll start with an overview of the AI Research Center that we have in Al Faisal, which is where I'm presenting to you today on campus here at Al Faisal University, in which we are a research center that leads cross-institutional projects in the area of applied AI. The AI models that we co-design and build with our stakeholders span different disciplines. We have in culture, heritage, in the arts, in the game development sector. Also, we are very active in the applied medicine and the health tech field, which is the focus of this presentation. Now, in our work, much of it is aligned with the national strategies, and we work with our stakeholders and partners to identify areas that are relevant to advancing the field in developing technologies that address strategic priorities in terms of solutions that help in the decision-making, or devices and instruments or tools that could help the practitioners in specific domains. And we do recognize in our work that AI is a means to an end. So we look for impact-driven innovations that may or may not implement intelligent engines or AI modules based on the need and the added value of AI for these solutions. So what we would like to highlight in the presentation that we have for you today are the use cases in which we showcase the alignment of the technologies in a specific domain, and we can also reflect on the spin-offs or the startups that emerged from many years of collaboration in this space with our partners. Now, moving on from the broader scope of the research center to the specific broader scope of the institutional center to the specific groups and labs that we have. As I mentioned earlier, we do have many areas that are being explored, and the research teams are tackling the problems in different ways and perspectives. We follow an antidisciplinary approach rather than a multidisciplinary approach, so that subject matter experts come together to solve a solution from different fields. As you can see here in the slide, we basically have 8 active groups. 3 of them are labs. That we have the Human-Computer Interaction Lab, which is our flagship and largest lab in the research center. We also have a robotics lab and a game development lab. And we have 5 research groups, each specializing in a specific area. We have germ technology group, human-robot interaction group, computer vision group, machine learning for health, in which much of our work is in collaboration with the College of Medicine in Faisal University. And we also have the conversational systems group, in which they focus on natural language processing, chatbots, and conversational agents in general. This is an overview of the center itself. And if we zoom into the topic that we wanted to focus on today, it might be good to highlight some of the active research projects from which the spin-offs emerged. And in this one slide, we're highlighting areas that are in the space of neuroscience and neurology, where many of the technologies that we build in the health tech field are focusing on cerebrovascular disease. So basically, in this line of work, our researchers, students, and collaborators look at the stroke treatment paradigm and look at the areas in which AI engines could contribute to the detection of hemorrhage or segmentation classification of occlusion detection or any abnormalities in the neuroimaging that is considered in such diseases. So what we look for is intervention or diagnostics that could help the physicians and the subject matter experts in the field. One example is the COVID stroke project, in which our teams would look at the images, the CT scans of patients that presented to public hospitals in the early few months of the pandemic. And it's a retrospective cohort study. They look at the design and development of AI agents that could learn from the labeled data sets that we have from physicians, so that we can identify any new ways that these diseases would present for physicians and practitioners or healthcare workers. Now, another example of diagnostic is the urgent care pathway application, Neuroemoji, in which we utilize facial recognition applications to help identify some diseases that could present with symptoms in asymmetry in facial features, such as Bell's palsy or stroke. So this would be basically in triage and, as I mentioned earlier, urgent care pathways. Now, beyond diagnostics, we also have some technologies that focus on rehabilitation, in which we could analyze the movement of patients, whether they are early stage rehabilitation or if they are ouch patients and have the devices with them. And we look at how we can capture objective metrics of the progress of the patient and how that can inform the course of rehabilitation for that target population. Now moving on to the specific scope of neurotech or neurotechnology. It's basically a growing space of digital innovation. It is at the intersection between neuroscience and technology. The AI Research Center is affiliated with the College of Engineering at Al Faisal, and we do have a software engineering program, but we collaborate in many of our projects with electric engineering, computer engineering, mechanical engineering, and industrial engineering for the ergonomics and design of projects. So it's multidisciplinary in terms of the tools and systems that we built, in addition to crossing over to the medical field and collaborating with our faculty in the College of Medicine for the applied domains in which these technologies would be used. So the overarching aim is to bring these applications, processes, products, services, or even the business models for the spin-offs and startups that emerge from our labs to deliver scalable solutions. Now, the aim here is to co-design it with target user populations. So we look at impact-driven solutions in which the clients and stakeholders were involved with us in the design process that sometimes spans 3 to 6 years, and they're involved from the beginning in the different iterations in which these technologies are designed, developed, tested, and then deployed to the market or to the practitioners. Another definition of neurotech being an emerging field is that it's a neuroscience-focused branch of health tech. It's commonly identified as such, where the players attempt to solve client-based challenges of people living with neurological disease, or the healthcare professionals that provide the healthcare services for these target user populations. Now, many of the devices that we currently work on and have been leading in the field for the past decade or 12 years are BCI, brain-computer interfaces. Now, these devices basically acquire brain signals, analyze them, translate them into commands that are passed on to devices that could be used for control, or in some cases, the actions would be simply to identify patterns such as seizure detection or abnormality in the way the human brain functions. It could be applied, for example, for learning difficulties, if it's dyslexia, or for hidden disabilities, such as some of the diagnostic that we design and develop for autism. The main goal of the technology itself, BCI, is mainly to replace or restore useful function to people who are disabled if it is designed and developed to be an intervention or a tool or an assistive technology for the target user population. Now, brain-machine interfaces, or BCI in general, they do measure changes in the brain activity, which often is an input to our engineers and designers, and utilizing it whether to scan, monitor, screen, or as intervention to control a specific action, device, prosthetic. The options are there. The technologies mature in terms of detection, but not yet mature in terms of the AI models in this space, and that is the area we are very much engaged in. Now, the overarching research questions that our teams have are basically, how might we use BCI to understand hidden disabilities? Because this information, if we roll back more than a decade, was not easily accessible to a technologist or an engineer, as it required MRI and more invasive procedures to gather that information. And right now, with an unobtrusive device of EEG devices, we have access to this activity in real time. So this research question is attractive to many of the research teams to explore different applied domains in cognitive disabilities. We also have the research question of how might we utilize such devices in interventions, rehabilitation, monitoring, and other applied assistive technology areas. Now, if we look at these focus areas in more depth, we'll dive in with a few examples of the fields that we have. Just for the sake of time, we've selected the most prominent research tracks. So what you see here in the photo was the think tank that we had for assistive and augmentative communication that relied heavily on Neurotech for many of the devices that people with speech impairments or cognitive difficulties would utilize for synthetic voice and speech. So basically, in cognitive assessment or screening for these kind of difficulties early on, if it's a speech impairment or if it's a cognitive difficulty, such as learning difficulties, dyslexia, dysgraphia, or others, we utilize these technologies to basically understand the person's abilities and how they rank within the normal, abnormal range for that specific ability. We also look at different modes of technologies. As you can see here, we have XR technologies, extended reality with virtual, mixed, and augmented reality. In other cases, we utilize BCI, brain-computer interfaces, and in some cases, sensing devices. Another applied domain would be cognitive simulation rehabilitation. So basically, they would have the objective of utilizing these technologies to improve cognitive deficit originated by lesions or illnesses that affect the optimal functionality of the brain through a digital solution. So the simulation might be visual, auditory, or specific signals that encourage mobility so that we build on the plasticity of the brain in such interventions or remedial programs. Other cognitive stimulation rehabilitation would be in the context of learning. Some are based on eye tracking, some are brain-computer interfaces that could help us in adapt serious gaming or applications that could help a person in overcoming a specific problem, such as dyslexia or with autism, interaction, social interaction, human-to-human interaction with virtual scenarios, or simply to identify coping strategies for such situations. Another area, focus area where we would have sensor-based telemedicine or telehealth would be the devices that we would design and develop to mimic the devices that are used in rehabilitation while the person is inpatient receiving that treatment, to see if we can extend the healthcare provision beyond clinical settings and have these devices affordable and sent home with the patient, so that real-time display of the data and the information, objective metrics of the patient's progress could be sent to the physicians while the patient is at home carrying out these recommended exercises. Examples are mirror therapy, where in many cases the patient conducts this to post-stroke interventions. So they conduct these exercises to simulate the activity that would be for an affected limb, so that the other limb would respond. Once a patient is trained on these type of exercises, the repetitive nature of these kind of exercises could be applied with a technology that captures and exports this information to a physician that can monitor and provide recommendations for the patients in that, with that specific condition. So this is an example of neurofeedback given in real time, or neurorehabilitation, where the device captures information, whether under the supervision of a physician in a clinical setting, or the patient would be using it independently from a remote location, whether it is a home or any other setting that is not in the tertiary care center. Now, to recap, basically zooming out, as I mentioned earlier, there are many different labs that are engaged in these technologies, the design development of these technologies. In some cases with Neurotech, the devices are built in-house. So in that case, we would have a computer vision group, the robotics lab, and the HCI lab collaborating. In other cases, if it's an applied domain of, let's say, remedial program or screening program that is gamified, where we would have serious gaming, then we would have the game lab engaged in that line of work or line of research. Now, the research model that we have engages students with undergraduate research courses in all areas of engineering. And we also have the model of engaging students as research assistants within our research lab. And this spans the College of Medicine, College of Engineering, and other colleges within Faisal University. We also have research projects embedded within the courses that we have in the many engineering programs, in which our engineers would be engaged in collaborating with our stakeholders as part of their courses to present a solution that is also assessed by the partner and showcased in the university's annual research exhibits that we host for students and our partners. With that, I thank you for the opportunity to share our work with the audience here in the workshop, and we'd be happy to take questions as part of this session. Thank you, Dr. Arij.
Thank you so much, Dr. Arij. It was very interesting talk, and I like a lot of the research area you're working on with the team. But could you please allow us to delay the question to the end of the session, please?
Absolutely.
Now we will welcome our second speaker, Dr. Manal. So Dr. Manal is an assistant professor at the Faculty of Computing and Information Technology in the department, in the Information Technology department. She completed her master's degree in 2011 and her PhD in 2017 from King Abdullah University of Science and Technology in majoring in computer science, focusing in her research as interest in bioinformatics, data mining, and machine and deep learning. And she can start now. The floor is yours, Dr. Manal.
Good afternoon, everyone, and thank you, Dr. Arij, for introducing me. I'm Dr. Manal Kalkatawi, and today I'm going to talk about how AI invading most of the scientific research field. The outline for our talk, we will start with a general glance about AI. Then we will talk about different research fields that are affected by the AI, for example, but not limited, natural language processing, biology, healthcare, chemistry, finance, and marketing. At the end, we will summarize with a controversial question. Will AI take over the world? I think all of us has that question in mind, and we will see. So if you allow me at the beginning, I'd like to hear from the audience, or I'd like you to contribute either by scanning the QR code or by checking this website that I'm already sharing. Can you?
We are sharing the screen, but we don't see the website.
Would you be able to see this link? It's called Mendeley. It's called Minty, and you can access this code.
And the QR code takes them to the same
page. So
okay.
either you scan the QR code or access this website and put on the code. If you did so, I'll give you just a chance. Then I'll share with you a cloud that shows you your answer for such a question. Which scientific research fields are affected by AI in your point of view, or what do you think? Business, it's mostly. Can you see my screen? Okay, computer science, medical imaging. I'm happy that most of the topic that we are going to talk about right now. Tourism, finance, great. Banking, great. Chemistry, great. E-commerce, cybersecurity, biology, yep. Medicine. So as you can see, you agree with us and we are on the same page that most of the scientific fields or the fields in general affected by AI or by the emerge of AI. So let me now get back to the presentation and thank you for your contribution. So we will start by an introduction about artificial intelligence. I'll just give you a glance about it, just to make sure that we are all on the same page. Because as you know that we are coming from different backgrounds. So artificial intelligence, the word artificial means man-made. So it is not natural. Intelligence means thinking ability. So what we are trying to do is taking something that is man-made and try to teach it how to think. AI is a study of how human brain think, learn, decide, and work when it tries to solve problems. And an important component of an intelligent environment is to anticipate actions of human inhabitants and then automate them. So the idea is that we want a product, man-made product, in which it can think and automate lots of things. The goal of the AI is to enhance both computer functions, which are related to human skills, and also to enhance systems that reveal the features associated with intelligence in human. I'm sure that you have heard about many terminologies like AI, machine learning, data science, and you might mix up or feel confused about them. In this picture, I'm presenting the big picture that should clarify some of your inquiries. AI is the big umbrella, as you can see. AI is the big umbrella that has the science, theory, and algorithms of simulating human intelligence. It started with AI. And then machine learning is the application of AI and has many functional algorithms. Data science is an interfering topic. You can see that it's overlapping between standing alone science and machine learning. It's an interfering subject that usually work in collaboration with machine learning, and you could get the most of that science. So the main nutrition for this big umbrella is the data, and we cannot work with AI or machine learning or data science without data. So let me just put some basis for this. What is the difference between the data and the information and the knowledge? The data, it's the first thing. It's an individual facts or statistics or items of information often numeric, that are collected through observation, while information is to add context to these data, to make sense out of these data. And knowledge is to interconnect everything together, or it's the expertise of wisdom to infer the result from the data and the information that you have obtained. So we will feed the data to the machine learning, or to the AI, trying to understand the context. So at the end, we will have the knowledge that will help us to take decisions. Overall architecture of the process of the data science that can be summarized in this. Most of the application, not all, but most of the application will go through these steps. The first is about data and business understanding, which is the problem understanding itself. Then the raw data that you have, you try to understand it and comprehend it before starting preparing it to access the model. Then we will do the modeling, try to pick an algorithm and feed it with a training data, and then apply that model on the test data, then deploy it in the production environment. At the end, we take the knowledge and the action which help us in taking decisions. So here are the scientific fields that we will discuss. Some of them I already have contributed in, and I'm going to talk about my work, and some others I'll just present the common AI research problem in the field. Let's start with natural language processing, which is mostly known as NLP. The most intriguing point in this field of study that it is a subfield of many other fields like linguistics, computer science, artificial intelligence. So it's interfering topic, and it is about how to program computers to process and analyze a large amount of natural language data, or the text data. So we need from technology, or this science, the natural language processing, to understand, then accurately extract information. So understand from the data and extract the information to move it to the next level, which is information and insights contained into that document, despite the type of the document, whether it's tweets, it's blogs, it's reviews, whatever. So some examples of the NLP task is speech recognition, which is usually converting voice data into text data. And then part of speech tagging. Speech tagging usually used like you know which part of the sentence is verb, which part is a noun, and so on. While word sense disambiguation, it's about finding the meaning of the word that could mean differently, like the word make, for example. Sometimes if you say the sentence, make the grade, it means achieve the grade, or make a bet, it means place a bet. So it takes from the context and give you the meaning of that word. Then natural language generation, it's like the task of putting structured information into human language. So it's like the opposite. You are trying to put, taking different things and generate text out of it. The most common thing is a sentiment analysis, and it is usually attempt to extract subjective qualities, attitudes, emotions, sarcasm, confusion, whatever type of sentiment from the sentence that you are providing, or from the document that you are providing. So the sentiment analysis, we will talk about it more. Sentiment analysis problem, the challenge usually facing in Arabic sentiment analysis, which we contributed in, it's mostly the different dialects of Arabic language. So there is a classical Arabic or اللغة العربية الفصحى وعندنا كمان اللهجات المختلفة, and that's might it is a challenge that facing the people who are working or the researchers who are working in Arabic sentiment. Then to solve such a challenge, we are proposing a machine learning model that could understand and classify the document. So the purpose is to predict the polarity of opinions and sentiment, and could be used also the Arabic sentiment analysis in fake news recognition or spam recognition. We started by having the published data set in which we analyzed, and then we built a model or a framework. We named it Deep ASA, using a recurrent neural network to classify that document, and we got a result could reach up to 95% of accuracy. Yet, we've noticed that there is an issue with the data. It is limited number of the data, it is outdated, and that's it. So we decided to make a project that is combined project between KAUST and Lucidia Company and KEU, in which we collected more than 100,000 of tweets using Twitter API in different topics. And then we hired people like manually to annotate these data sets. And then we took the majority voting to give a class for each tweet. And at the end, we got the ASAD dataset, which is available to be used by researchers. Yet again, we found that this data, even though we worked on it and it is manually annotated, and it is a huge number of data, it could be outdated. So because it's using tweets, it could be outdated. It is not a sustainable solution. So we worked on finding the Arabic sentiment or the annotation of the text using a systematic technique or a framework. We called it AAA, that take this data set that we originally built to generate models that using a clustering with different type of a clustering, then we evaluate it. So by clustering, we can annotate the test. And we got an 87% accuracy, and I think it is good enough, but it needs more improvement. Let's move on to biology. This biology science, when you add to it the AI, it is called bioinformatics. So what is bioinformatics? It is an interdisciplinary field that develops methods and software tools for understanding biological data. It can be used to gain biological knowledge, to understand genomic organization, to discover a gene, to relate gene and disease association. So this is the world of bioinformatics. We started working on this field by genomic signal and regions recognition. In this problem, all eukaryote species share a complex gene structure, which is surrounded by various control signals, in which each has its own function and characteristics. Many eukaryotic genomes have not been fully discovered, so the study of well-annotated genome may help identify the undiscovered genome. So I don't want to talk a lot about biology, but I'm happy to explain offline if you like. However, let me mention that in this research, we focused on translation initiation sites and polyadenylation signals. And why these two? Because any mutation in these signals could cause diseases. So we started by dragon polyase sputter, which is only for polyadenylation signal for 12 variants that is coming from a human mRNA sequence. And then we got an accuracy that is around 94%. Yet, this is a very specific solution for polyadenylation in human. So we worked on deep GCR, that is a comprehensive framework that can work on any type of genomic signals and without any handmade features. The intriguing thing in deep GSR, that other than accepting different genomic signal and working on multiple organisms like a cow, a mouse, a fruit fly, and human, also we represented the data that is textual into 2D data. So the results that we already published, that for the polyadenylation signal, we had the lowest error rate, the same as for translation initiation sites. Then another field under bioinformatics is the functional genome annotation, which identify and denote a function of different segments in genome sequence. Why we need this? Why do we need like functional genome annotation? Because if you try to take any organism, especially the prokaryotes, and you upload them to take the annotation for them, you will get inconsistent annotation. So what we will do to solve such a problem, we will compare and extend and derive the annotation, and it can be used for re-annotation projects and help and it's gonna be a very great help to researcher. So this is Beacon, another tool that we've built that takes multiple annotation for the genome from different tools, putting some global characteristics and local characteristics for each annotation file. So if you want to annotate, for example, a genome, you might go to different tools like NCBI, AMG, RAS, BG7, a lot of tools that can annotate the genomes. You determine one of them as the reference, then you can see the gene in comment. Then at the end, we will do the extended genome, which is increasing the number of functional genes and lowering the number of orphan genes that has no functionality. Here is a summary of what you can expect as an output from Beacon. It's the annotation from NCBI as a reference genome and different annotation. And then the most important thing is, as I said, the minimum number of orphan genes and the maximum number of functional genes. Moving on into the research fields, we will talk about the healthcare, which is a mix-up with biology a bit, but in a more broad and high level into the medicine. So what is in healthcare? Usually the AI contributed in healthcare for medical image processing, for example, decision-making, ranking the different cases, and trying to reduce the error. So firstly, for example, one of the research areas that we worked on is breast cancer detection from medical images. The problem that motivates us to work on this is as the Saudi Ministry of Health, for each 8 women, 1 woman will be diagnosed with breast cancer. So suggested solution is to provide a system that the user can upload their mammogram, and then we predict it with the vote with other doctors to prove the result or give it the probability of having the breast cancer. The motivation behind this research problem is that the early detection of breast cancer could increase the rate of recovery up to 90%. This is like a picture diagram that explains the eDetect system, which is the user can upload the mammogram into the system, and the system will study it using the deep learning as well. And then the diagnosis will be from 2 doctors, and the third one, it will be the machine or the model, and the majority vote will be conducted. Another healthcare assistant project is emergency call assistant system for incidents call handler, which is a system that is used mainly to predict the emergency case by the injured person will answer some automated questions, and that questions will be translated into text, so voice to text, and then the analysis of the text will be using a machine learning, which is support vector machines, and then you will transfer the case to the department in charge. The classification result, it's 72.7%, which is acceptable but not good. It needs more improvement. Lastly, in the healthcare, the detection for the current pandemic that we are in is COVID-19. So we want to detect COVID-19 from CT scan images. We worked on a data set that is already published. We did some type of pre-processing like segmentation, and then divide the data into training, validation, and testing. After that, we built a model using the CapsNet, and then we classify the images into multi-classes like corona or common pneumonia or normal. So it is a multi-class classification. So out of that research, we find that the CapsNet can extract COVID-19 features from CT images with a low false negative rate, with the accuracy around 79%. And the effect is that limit those people who have a negative results from spreading the virus. So it is like an assistant diagnostic technique. Next is a research field. I think I have to hurry up a bit. So chemistry, again, chemistry, it's like biology. It is called, whenever the AI interfering with chemistry, it is called chemoinformatics. Chemoinformatics, it's a term that has been coined recently to describe a discipline organizing and coordinating the application of computer in chemistry. So a chemistry as a standalone, it is a science by itself, but when we add the AI to it, it's gonna be chemoinformatic, and it is extensively used in drug discovery, and also it is interfering science like pharmacology, bioinformatics, and chemoinformatics. All of them can be connected together into one study. For example, the drug repositioning, and it has many synonyms like drug repositioning, drug repurposing, drug reprofiling, therapeutic switching, drug retasking, all of them referring to the same thing, which is taking the already approved medicine and try to find another usage for it. Why we are doing that? Because repositioned drug, it's already approved by the FDA. So we don't need to go through the whole process, like de novo process for finding a medicine, or the safety or the toxicity testing and all of that. So it's a lower cost and faster therapy for the patients. The computational methods that can be used for drug repurposing is drug target based, which is usually based on chemical or pharmaceutical perspective. For example, not limited, chemical similarity. So it is based on quantitative relationship between chemical structure and biochemical activity. So extract the chemical features for many drugs and relate them to each other. Or molecular docking, which is discover the relationship between the chemical ligands and target based on simulation and modeling of their direct physical interaction. Another method, computational method, is disease-based, which is based on the clinical perspective of a disease or its pathology and symptomatology. For example, the side effect similarity. If two medicines have the same side effects, one of them can be used for another. So the basic hypothesis is the side effect associated, for example, with drug D are also induced by many of the drugs treating disease X. Then drug D should be evaluated as a candidate for treating the same disease. This is the general concept. So in this diagram, we summarize the different techniques that can be used for drug repurposing, the different technique and the subfield inside it. For example, you have the simulation, the direct and the indirect repurposing, and which one using the chemical, the side effects, and the molecular docking, and so on. Just one success story that I want to mention. For example, the researcher at the Ohio State University created an AI model to identify drugs that could lower the risk of heart failure and stroke in patients with coronary artery disease. So when the drug repurposing research was done, they found 9 drugs that could fit this criteria. 3 of them were already in use and 6 were not. So they tried to use it, and that proves the research for drug candidates beyond human capabilities. Of course, there are much more examples for this field. Moving on to another research field, which is the finance. Mainly the finance or using the AI in the finance can free up personnel and improve the security. According to Forbes, which is a magazine for finance, 70% of financial firms are using machine learning to predict the cash flow and adjust the credit score and detect fraud. So the application for finance, usually it's a tailored product, chatbots, client services, credit card like eligibility, credit clause, anti-money laundering, fraud detection, and all of that. One of the research that we already funded for, but it is under study, it's not already published or anything. It is credit card fraud detection, which is the process of identifying the purchases attempt that are fraudulent and rejecting them rather than processing the order. So at the beginning, you see the transaction, already you have a trained model that is trained on the anomaly. It's this field of the AI, it's called anomaly detection, in which you already know the fishy transaction and you can spot it before processing it. And this is called credit card fraud detection. Lastly, let's talk about marketing, and it is a trend these days. It is a method of leveraging customer data and AI concept to anticipate your customers' next move and improve the customer journey. It's all marketing. You can say it like advertising. It is all about the customer. It is customer centered to improve its journey. So marketing usually uses the AI to automate the decision. So for example, if you have a customer profile, to learn how the best to communicate with that customer, how to the best to tell messages to that customer specifically without intervention from marketing team. So as a case study, for example,
sorry to interrupt, Dr. Manal. I'm really sorry. I'm enjoying your talk, but we need to, if you can.
Okay. So let's skip the case study and move to the summary. The scientific research and the digital transformation and the job market, which is all about this symposium, are all leading us to the invasion of AI in most of the fields, as the whole symposium told us about. So lastly, I'll finish with, will AI take over the world? I think this is a controversial question. Many of us may be afraid from the future, but the future is not clear, and let's not be afraid of it, just go through it and get most of it. So acknowledgement to all the co-authors, and these are the references, and thank you, and sorry that I took longer than expected.
Thank you so much, Dr. Manal. And now we will have our third speaker. Sorry for the delay, Dr. J. And our third speaker is Dr. J Siegel. He is an educator with more than 35 years in STEM research and higher education development. He received his PhD in chemistry from University of Princeton, Princeton University, sorry. He worked as a professor in UCSD from 1986 to 2003, the University of Zurich from 2003 to 2013, Dean in the Tianjin University, 2013 to 2021. And so we would like to welcome you, Dr. J. Thank you for being here with us. The floor is yours.
Thank you very much for that extensive introduction, and thank you to KU for organizing this meeting, and for my colleagues who've presented really fantastic lectures about the details of AI. What I want to address today, and fortunately I don't have to go into the details of AI, we've heard now quite a spectrum of those applications and advances, but I want to talk about how AI and an associated manifold of IT tools are changing the future perspective of what a university campus will be. And so I'm going to talk about what I call the Cybernetic Campus and the culture that is created. Right now, if we think about the classical medieval campus, it's one that's based around a library for its archive of information. But what defines a cybernetic campus is one that makes a commitment right at the beginning to build the campus around the concept of the high performance computing as the core element of the university, the core functional element of the university. It sees this high performance computing as a major enabling technology for students and scholars, I should say as administrators as well. And it's ready to employ the full spectrum of these high performance computing tools in order to facilitate and enhance the institution's overall mission. That is the education of human beings to be better citizens and contribute more greatly to society. And we'll go over in a minute how this means that you have to accept the fact that the grid cloud has now become the new archive of human knowledge, which is something new, and I don't think people accept that generally. And understands that the power of a distributed archive and a distributed communication network really has the opportunity of increasing accessibility to higher education more globally, a democratization, if you will, of higher education. And that allows us to reaffirm the primary directive of education, which is the primary directive of education to the betterment of people through their intellectual expansion and maturation. Quickly want to go through a little bit of history because I think this kind of places it in a very humanistic context. If you go back into ancient Greek, the word cybernetic comes from kybernetes, which is a Greek word, and it comes from the term of a ship's helmsman or steersman, someone who guides a ship along either during war or during some sort of navigation. And this helmsman needed to be someone who could be an archiver of knowledge, had to be a quick problem solver, think analytically as to what was useful, and had to be a commanding communicator so that the oarsman knew what needed to be done to move the ship in one direction or another. And very much this was appropriate then when Plato talked about the ship of state, where he created a metaphor in which the social leaders needed to be the kybernetes of society. They needed to archive the knowledge of society. They had to be able to solve problems on society, and they had to be able to communicate. They had to be commanding orators in order to get this through. And we can see parallels of that developing in the tutor scholars who are developing those social leaders, who are developing this intellectual elite class. And therefore, these teacher scholars were in fact the Cybernetics of their students and disciples. This meant that scholarly institutions followed the man. I guess in a modern context, they would follow the man or the woman, but of course, in antiquity, it was almost 99.9% of these, there was very little access, unfortunately, for women in the antiquities to do this. And you could see this literally in the concept of the peripatetic school. These are now Socrates or Aristotle key scholars who would wander the countryside with their group of students. And there was, in fact, a university, if you will, a scholarly institution without a campus. But as time goes on, the embodiment of knowledge then moves into texts. It is encoded into scrolls and books. And suddenly the human, the individual human, is no longer the archiver of all information. In fact, one begins to very quickly write things down and store them in text. And so we go from man or from a human into a text society. And after many singular texts are important, treaties and monographs, eventually this gets to be so large that we need an archive to put them somewhere. And this comes then to the concept of the bibliothèque or the library as the archive of human knowledge. And as soon as you do that, you create a change in the way you think about scholarly institution, because now there is a place, there is a de facto place where you place all of these books and texts, like the Library of Alexandria, and people go to that watering hole, they go to that place, and it changes then the overall culture. People can take books and sit alone and read them. It reduces the amount of interaction. And in fact, then we see that the library as archive becomes the main core of the university, certainly in medieval times at Bologna on forward, and that we then see the development of university structure mimicked on the taxonomy of the library. And so all of these ideas of disciplines, whether it's chemistry or medicine or sociology, in many ways are related to the fact that if you want to understand something in chemistry, you look for the books on chemistry. They're sitting in one room of the library. But if you want to look at the books on Shakespeare, they're in a different room in the library. And so the structure and taxonomy of the library imprints itself on the way we develop our structure of the university. However, more recently, what we see is that high performance grid computing, the grid and the cloud and Internet of Things, which I'll talk about more in a moment, these advances have shifted the archive of human knowledge away from the library. At a university these days, more coffee drinking and socializing and studying and writing go on in the library, but you don't see so many people going to the library to read books. And that's in part true because the book has now been replaced by a spectrum of handheld and laptop devices, that we no longer have a single volume of a book that we take away and read, but with our phones or with our iPads, we can very quickly access 1 million different books or 1 million different subjects, or not even a book at all, just the raw data or live data coming in. As a result, in principle, a physical location is no longer needed as the watering hole for scholars. It's no longer a place that you have to go physically to drink from this fountain of knowledge, if you will. And interpersonal communication can now span the globe. My peer from Zurich can be someone in China or in Saudi Arabia or in Brazil. And that means that suddenly I'm not looking just to colleagues within the same campus or within the same village, but I can become part of really of a global scholarly society. And the knowledge that we acquire is no longer so contextually constrained. When I want to know something about acidity, I'm a chemist, so let's say I want to know something about acidity, I would go to the chemistry section, I'd get a book on chemistry that had a chapter on acidity, and I would open it up and I would learn what chemists think about acidity. It was very, very context dependent. But today, if I go into Google or one of the search engines and type in acidity, I don't get just the chemist's view of what acidity is. I might get a literary interpretation of what an acidic or vitriolic personality is like. I might get a construction view of what or a soil conservation view of what acidity is. Suddenly, the context of what I'm looking for comes back to me as a multidisciplinary factor, and that means that the questions I ask automatically come back answered to me in a multidisciplinary perspective, and I don't have to keep thinking of myself only as a chemist or only connected to the taxonomy of the library of before. Now, modern cybernetics was something that I guess coined by Norbert Wiener in around 1950 in a book which he talked about how humans use human beings. And by use, he didn't mean this in quite the sort of capitalist sense, but how it is that through our interactions, how our communications induce us to sort of make use of one another. And so this theory of messages or actions between man and machines, between machines and man, and between machines and machines, this developed into what the modern definition of cybernetics is. And the hope for this was that through these human relationships, first through automation, which I tend to call as robotics, and what I call AI, I call autonomization. That is the embodiment of a machine that begins to make decisions on its own, or the enhancement in this triad of man to machine to man, and machine to machine, that basically AI is enhancing the machine-machine component, because the intervention of the human being is less and less needed. I think that we can argue or discuss about that later, because of course that brings up the fear that if the machine-machine component becomes dominant, then what's the need for humans at all? How does this dehumanization result in supplanting man-man relationships? And as our last speaker ended on the question, will AI take over the world? I'm not so worried about it taking over the world, but I am concerned about how we incorporate into AI ways to enhance human-human relationships and not just enhance machine-machine relationships. And let me just give you a quick example of that. If I took a series of data in an old-fashioned way, X against Y, and I taught you how to do a linear regression, you would see a line of best fit that would come out by some it could be automated, but also hand-done set of calculations. But after doing 5 or 6 of these, you could pretty much look at a raw set of data, and you as a human being would already begin to see the pattern. Right? So this idea of intelligence is really, as also this wonderful slide earlier, we take raw data, we contextualize that raw data, turning it into knowledge, and then we put it into a network so that we can make predictions from a pattern that we recognize. We recognize a pattern and we see from that pattern and anticipate what is yet to come, or what a decision will do to that pattern of data. But with AI, one of the fundamental differences is that the data that's coming in is so plentiful and so complex and has so many subtleties that it's almost impossible for a human being to look at an AI regression set and see the pattern. We get the answer, right? We get the predictability, we get the outcomes that we want, but do we gain the understanding as human beings? Is it any easier the next time for us to do the analysis ourselves, or do we always have to rely on AI? So these cybernetic tools then are going to be these computers. It's a hardcore infrastructure, the highly connected grid network and Internet of Things. And an Internet of Things is simply an internet in which every item, every device, every human being, every instrument, every location is given a point on the grid. and then becomes interconnected to one another. And so if you walk up to a machine, the machine recognizes you because you're a point on the grid, it's a point on the grid, and it talks to you and you talk to it, and it tells all the other machines that you're there and what's going on. And it's really nothing more complicated than that. We need these massive cloud and machine-based data archives. We need the tools of robotics and automation. And of course, the theme of today, artificial intelligence and autonomization. We need to have tools then where we have the confidence to allow the instrument, allow the machine to make decisions, quote, on its own or in consultation with other machines, not necessarily with other humans. So ultimately, the Cybernetic Campus then is going to be a pedagogical organization or organism based on the systematic analysis of or designed around the theory of man and machine, machine and man, and machine-machine interactions, but with the goal to promote human self-awareness, self-agency, at the same time enhancing human-human communication and sensitivity. So the elements of a cybernetic campus, this is something that would be very difficult to take, let's say Cambridge, to take Cambridge and put a research institute that's doing cutting edge AI work is easy. To take Cambridge and turn it into a cybernetic campus is not. And that's because you'd have to really start from the ground up with the assumption that we're going to build the whole curriculum, the whole concept of the university around this HPCC network, this HPCC infrastructure. And that curriculum would have to leverage the hyperconnectivity as well as the distributed nature that this grid would allow you to use. Would it use the potential of an IoT to facilitate operations? If every door knew who you were, if every NMR knew who you were, and whether you were trained to use it, whether you were allowed access, it could very much facilitate the ability to move around and to negotiate things throughout this campus structure. And that means you could have much better safety and security measures on campus. And in principle, the administration could do this to simplify and enhance not only logistics, but also research and teaching. It's going to require us to rethink what the core curriculum is for new students coming in. Those communication skills are going to be a priority, and not just the verbal ones that we've been teaching, how to write and even how to give a PowerPoint presentation, but how do we manipulate imagery? Young people are using TikTok in an unusual and large way, an effective way, because they seem to naturally have an understanding of how to use visual arts and visual communication. The world of the university has to catch up with this. Programming skills will need to be as universal as language skills. English will no longer be the international language of everything, but in fact, programming skills, being able to create an app, to talk with machines, to understand how machines work will be crucial to every scholar, not just to STEM scholars. Quantitative skills will have to focus more directly on explaining world experience, because AI is not going to provide that. It's not going to provide the understanding component. And so that means that people need to feel comfortable and fluent with robotics and automation. AI will have to become a tool. In fact, most of the examples we saw today were not in how to program AI or how to move AI forward. They were saying, okay, we have this tool AI, how do we put it in an app so that we can then get to the answers we're looking for more quickly? How do we get the pattern analysis and the data optimization more quickly? And ultimately, we have to place this in a socially responsible context so that we can reaffirm the importance of human-human interactions. We got to retool the faculty. The faculty need to become more tech savvy. They need to understand that they're not going to be simply instructors sending out knowledge, but are going to be more mentors trying to help students. There's going to have to be more experiential learning outside the classroom. I could imagine the university of the future in which there are no classrooms. One will understand more and more that high school will end the consumption of information. College will begin the production of information, and therefore a college degree will have to be capstoned by some sort of research. So teaching and research will have to find a common overlap together. And that means that we should develop also an appreciation for that disciplinary knowledge is good for certification of a skill, but intellectual maturation and advancement is really what we want to be doing in the university. The student will therefore take over greater agency. There'll be a much larger nonlinearity in education because students will then take over responsibility for their own education, and they just simply won't need poor teachers. They will then become sooner their peer-to-peer mentors. And so they will have that as a way to give back to the community, but also to demonstrate in the real world their competence and understanding by helping their fellow students learn. They will have to, of course, they already do this, but they will have to leverage the hyperconnectivity so that they can access knowledge that goes beyond the limits of discipline. They can't come in and say, oh, I'm going to be a psychology major or a communication major, but that I'm going to be a scholar. I'm going to learn beyond these disciplinary components. And of course, they have to make efficient use of the technology to become an autodidact. The administration will have to rethink the university structure and therefore will have to provide the resources. And that means really going out and figuring out how they're going to retool the university to a cyber structure upfront, to acquire the necessary infrastructure for these things, how to educate and empower the staff in the tools of a cyber structured campus so that the staff can produce logistics and procedures that will be now more transparent. And therefore, by use of these cyber tools and IoT, we can make a campus that is that has a culture which is simple and transparent, and it's independent of the point of origin, age, gender, race, or persuasion of our community, whether they are the professorial or student scholars. All of this, I'm coming just only last slide here, all of this comes down to a chance for us to re-envision campus principles of community, right? There's no point in having any organization if we can't ensure the safety and security of the community. That is the essence of society, and it's the essence of every organization. We cannot ask people to come together if they do not feel safe in that home or they do not feel secure in that home, whether it's because they don't feel physically or mentally safe and secure in that. And so I think that can be done quite well if we manage this in the cyber campus mode. A primacy has to be placed on personal responsibility, this idea of becoming an autodidact, of having personal agency and responsibility for your own education. Education of and enrichment of the student is in fact the primary mission, because those students who come out having experienced that primary mission will be the ones that operate in the research centers and in the business centers and in the political centers as much more effective citizens. And as I said, because the creativity is so important, innovation so important in modern society, then research will have to move into the undergraduate education as the capstone proof that you've actually accomplished your degree, that you've actually achieved the educational maturation that we're looking for. And the goal, of course, is to serve society by forming a great citizenry, a belief that the diversity is what's going to drive that innovation. People who think differently than us are the ones who are going to cause us to think differently, think outside the box. And therefore, you take all of these tools so that we can create a commitment to improving human welfare overall and advance global connectivity and understanding. So anyway, I tried to share with you a little bit of my vision of what the university of the future might look like and how that campus could be embodied around a cybernetic campus culture. Thank you very much for listening, and I'm happy to answer any questions.
Thank you so much, Dr. J. And now we will take the questions. I see that a couple of the audiences, like they wrote some questions and Dr. Arij already answered them. Dr. Arij, you want to mention anything regarding the questions you answered?
Thank you, Dr. Hodali. I believe the questions were aligned with the products that were highlighted in our presentation, related to how mature they are, or are they market ready. And in my response, I emphasize that it really varies depending on the type of technology. Is it in a pipeline for clinical trials? So we go through a rigorous process in making sure that the technology is safe, the technology is designed in a way that matches the expectations of the partner, whether it's for clinical use or it's co-designed with a patient or a proxy for a patient. So the time span for such technologies would be 3 to 6 years on average. And this would be aligned with some IP disclosures, some cases it would be publications. So it's evidence-based and it varies. So we can point to specific technologies if there's interest. And in response to the first question, I shared the website and the email for our research center, and our teams would be happy to engage with the community if they would like to understand more about any of our ongoing projects. Thank you, Dr. Hodali.
Thank you so much, Dr. Arij. There was like a few comments from other member. They just mentioned that some of them, they're just thanking everyone, the speakers, and suggesting that we more like comments and suggestions. I don't see other questions, but I personally have a couple of questions, and while we receive the other questions, a few of the concerns that people are having currently is that the common concern in the AI field is usually they have concern about the model is being biased, or the privacy issue, and these kind of concerns. How do you believe that we can explain that to someone who is not in the field? And are these concerns are valid from your point of view, or not valid, Dr. Arij and everyone?
Thank you, Dr. Hodali. I think unpacking that question might require another session. Briefly, I would say the different areas of AI would have different responses to those concerns, because the maturity level and the concerns linked to the ethics and the way these systems are designed, developed, or even deployed, or the context might vary. So it's very specific to the subdomain, because with the applied AI, it's broad, and the challenges vary in relation to the users and target populations, in addition to the context of use. And with that, I'll pass on to our fellow panelists so that their perspectives could also be shared with the audience.
Sure.
Back to you.
Dr. Manal and Dr. J.
I'll wait for Manal. She was the second speaker.
Sorry, could you explain the question again?
I'm asking about the concerns that usually people who are not in the field usually they raise, which is about the model, or they're afraid of the model being or any kind of system being biased towards like a specific gender, let's say specific kind of ethnicity, or these kind of things. And what is the best thing you think? How can we respond to these kind of questions?
So we should admit that the models are data dependent, actually. So some data may, some models may perform well with a specific type of data, but not with others. So it is something that we have to admit that the problem solving using machine learning is a data dependent. But the thing is that usually whatever model that you are training is usually used for the same problem. So if you used it for business, that means that the testing data will be for business. So and if you want to use the same model for another thing, you have to do some tweaks to match the new data.
So I think one has to recognize that there are actually two sets of truths in the world, right? There are absolute truths and there are empirical truths. I don't want to talk at all about absolute truths, but the one thing that's true about empirical truths is that they are derived from experience. And all experience is a kinetic process that has a bias associated with it. And so again, take a chemistry example. One of my students said, Professor Siegel, why is it that we learn so many ways to make 6-membered ring carbon compounds and almost no ways to make other things? And the simple answer was that the burgeon of chemistry occurred when steroids were very important. And steroids are a big cluster of 6-membered rings. And so our experience and our goal was to make these steroids. So everyone learned ways to make 6-membered rings. And so our tools are populated with those examples. They are biased in that way. Similarly, any type of analysis, if I give you a set of points and I ask you to find the best line, then I've already created a bias because I've told you that to go look for a line. But if the data is actually a parabola, the procedure will still grind out what the best line is. The big difference between that and AI is that I can look at the data immediately. It's simple enough that I can look at the problem afterwards and I can readily identify the bias and I can correct for that. And so the fact that we know all data is biased, and the fact that we know that the selection of the optimization method will also force the answer to be biased, really means that we need ways to be able to look at the answers that come out and decide whether they actually account for the things that we want them to account for. And I think we need to make the community more confident that this can be done in a transparent way. And that's something that's, I think, computer programmers and people who use AI are going to have to think a lot about.
Yeah, that's a great point. Thank you, Dr. J. And I don't know if there's like more questions. Let me see. Yeah, there's I'm not sure, there's one of the audience, he's asking a question, but I'm not sure he's asking whom exactly. I'm not sure who can take this question. Faiz Khan, he's asking about, can you mention any application of AI or machine learning in the field of rehabilitation?
I'd be happy to take that question within the scope of what was shared today for rehabilitation. Two quick examples would be in terms of mobility, a mirror therapy, where it's a rehabilitation therapy in which the movement of limbs, upper limbs and lower limbs, would be mirrored to utilize the plasticity of the brain and help the body recover from strokes or any other cerebrovascular disease. With the goal of moving the non-affected limb so that we give the brain the illusion of normal movement in the affected limb. With the setup, the AI modules help identify different brain regions for movement, sensation, and understand the pain threshold for the patient, and it's adaptive in terms of the remedial program. Another example is AI-driven technologies, VR, AR for mental health, and that would be phobias. So So for patients to overcome a phobia of heights or a phobia of spiders or a phobia of any type is to gradually expose them to these under the supervision of a healthcare provider. So the AI model would actually monitor the physiological senses of the individual and objectively measure the anxiety levels of the patient so that the adaptive program would be aligned to that specific patient, and the physician can have a full picture or holistic approach to understanding what the patient is going through as they advise them in these applications. So technology helps a lot in that space. So back to you, Dr.
Yeah, thank you so much, Dr. Arij. So I think these are the questions. Thank you, everyone. I enjoy everyone's presentation so much, and personally, actually, and thank you so much for being for participating in this event. And inshallah, we will have more events in the future, and we will be happy to have you as a speaker. Thank you again for everyone. And with that, we conclude and finish the last session in this symposium. Thank you.
Thank you, everyone. Thank you.
Thank you
for having us.
Thank you. Thank you.
Thank you all.